That's disgusting.
Ahi ahi marie tai tamariki. Now my haere mai. We're going to have a lesson on the normal distribution. You're definitely going to see this on your external, and along with two-way diagrams and probability trees, we're going to be using the normal distribution to find the probability that something happens. Okay, have a look at this data. We can see most of the values are in the middle, and it's got this sort of bell-shaped curve. That's a normal distribution, and we are measuring something here. This is not a how many. They're measuring something in height. Okay, so you're always going to have something here that's being measured, and most of the things are in the middle. Now, some distinct features of the normal distribution, we should write these into our notes. They're symmetrical in shape. This curve, the left side looks just like the right side, so we say it's symmetrical. Most of the data is in the center of the graph. Okay, look what we're measuring here, frequency, or how many of something we have. There's a lot more of these garden gnomes, around 32.5 to 35 centimeters in height. That's where most of them are. And there's some that are smaller in height, but there's less of them. All right. So most of the data is in the center of this graph, tapering away to the ends where there's not much data. Those are normal distributions, and they're going to be very useful in you being able to find the probability in statistical experiments. And it's always going to be continuous data. As I was saying, these are heights. We're counting how many heights, and a height is a measurement. It's not counting how many traffic lights, or it's not counting how many students. It's never going to be a count. You're always going to have something here that has been measured. And that's what we mean by continuous data. Moving on. Many real-life situations are going to be modeled using this normal distribution, and since the data is continuous, probabilities are found in an interval, not at a single point. Below is an example of a normal curve, which we will call a normal distribution. As we can see, it's similar to the shape from the one on the previous slide without the bars. So there's no measuring, the counting. It's just a generic normal distribution curve. As we said, the features of the normal distribution are symmetrical in shape with the mean or average right there in the middle. Whatever value is there, that's the mean, middle, and average. As we said, it's bell-shaped. There is a singular mode. That mode is going to be, that one mode is the highest. You're not going to have multi-modes and be a normal distribution. Mode is also in the middle, and in a normal distribution, the mode is equal to the mean, which is equal to the median. Most of the data is in the middle, with only a small percentage of values at either end. Okay, now there's two things in a normal distribution that you're going to want to be looking at. One is the mean, and we use the Greek letter mu for the mean, and the standard deviation, which is a measure of spread. Standard deviation, you could think of like the range, biggest to smallest, measures how spread out the data is. Well, the standard deviation here, sigma, this is going to be measuring a standard deviation on the data, and standard deviation is also a measure of spread. The more spread out the data is, the bigger the standard deviation is going to be. The closer together all the data is, the smaller the standard deviation, because again, it measures how spread out your data is. In a normal distribution, most events lie close to the mean, which is there in the middle, mu, that's the mean, and very few occur far from the mean. The farther away you get from the mean, the less likely it is for a data point to be there. Now here's going to be something else for our notes. The standard deviation gives us a way to measure the probability of an event lying in a certain range. So we can predict how likely it is to be a certain distance from the mean. 68.2% of all the values lie within one standard deviation of the mean. So there's the mean. If you go one standard deviation that way and one standard deviation that way, this would be one standard deviation below, above the mean. And 68.2% of the data is in the one standard deviation. If you cut that 68.2 in half, 34.1, so those two together are within one standard deviation. You go to two standard deviations, -1, -2, and +1, +2. This is now 95.4% of all the data will be within 2 standard deviations, and 99.7 is within 3. Please make sure you get that in your notes. Draw that out. Those numbers are very important. Definitely worth memorizing, as you cannot bring a note sheet to the external. Later, we're going to explore some more detailed methods for finding the mean and standard deviation for normal distributions. For now, we need to know these simple rules of thumb. It's so important, it's there twice. Get that in your notes. 99% of the data lies within 3 standard deviations of either side of the mean. And that's what we mean by this. There's the mean, mu. Now, this is mu minus 1 sigma, or this is 1 standard deviation below the mean. Mu minus 2 sigma. So we're now 2 standard deviations below the mean. As we said, 99% of all the data is within 3 standard deviations above or below. This means that most of the data lies within 6 standard deviations. 6 times sigma is 6 sigma. And I wanted to point out, there it is. The range of all the data is approximately 6 sigma, or 6 standard deviations. There's 3 below the mean, there's 3 above. So the range of your normal distribution is approximately, squiggly equal sign, 6 sigma, or 6 standard deviations. So important. Get that in your notes. Commit it to memory. If you're not sure what the letters mean, please do ask. And the values for mean and standard deviation can and will vary. The mean and the standard deviation are going to be different from data set to data set. And this can affect the spread and height of the curve. Diagram below shows 2 normal distributions with the same mean, same mu, right there. But they're very differently shaped. Let's have a look at these. So when the data is closer together with a tighter, higher peak, smaller standard deviation, the data is more condensed, more consistent. Where the blue one has a bigger standard deviation, this is more spread out. So it's showing more spread out. The more spread out the data is, the bigger the standard deviation. When the data is more consistent, less spread out, smaller standard deviation. Thanks for watching. If you need to come back and watch this again, please do. Email me any questions. Thanks for watching. Mauri mahi, mauri ora.